Hi class, so I continue the next topic. Okay, when you look at capital Fs, if Fs or if the function is not included in table of Laplace transform, what you have to do is you can remember two things. The first is you try to factorize denominator and then you can use partial fraction. Okay, the second thing is if you cannot factorize, okay, you have to use completing the square. If you see the denominator is not in table of Laplace transform, you have to remember two things. The first is you can try to factorize and then use partial fraction, and the second thing is try to use the completing the square. Okay, this is the tips. Okay, before we go to the example, you have to know this one first. Okay, recall your knowledge about partial fraction. Okay, in this note we list you 5 things. Okay, you look at the first one, a linear factor s plus a. Okay, you can see this is linear. Okay, we can say that as plus b. Okay, linear. So if denominator is linear, so the numerator become constant. So okay, this one is denominator. For numerator, you need to just write constant. Okay, the second one is a repeated factor. For denominator, s plus a square. Okay, if the function is repeated factor, what you have to do is a over s plus a plus b over s plus a square. Okay, I will share with you how to get the number 2. Number 2 is repeated factor. S plus a square. Okay, let's say s plus 1 divided by s plus 3 square. So this one we can let t equal to s plus 3. So you will get s equal to t minus 3. So you substitute t minus 3 plus 1 divided by t square. So you get t minus 2 divided by t square. Okay, and then you do this partial fraction, you will get at plus b divided by t square. Okay, so you will spread this plus b over t square. So you get a over t plus b over t square. Then you substitute back. What is t? So a over t is s plus 3 plus b over s plus 3 square. So that's why we get in note a s plus a plus b s plus a square. Okay, that's why you get this. Alright, number 3. Similarly, if you have s plus a cube, so what you have to do is a over s plus a and then b over s plus a square, and then you repeat c over s plus a cube. Alright, and then a quadratic factor. If denominator is quadratic, so numerator must be linear. Okay, quadratic. So linear over quadratic. Okay, the last is number 5, repeated quadratic factor. If you have quadratic but repeated, which is square, so what you have to do is same thing, you repeat this. Okay, this one is linear over quadratic, and then plus linear over quadratic square. Alright, this is the tips. You don't need to memorize this one, you just try to understand this and you can answer the question. Alright, so we can look at the example. Okay, before we start the example, the tips when you deal with the fraction is, first when you look at the denominator in quadratic form, so you have to factorize the denominator first and then you can use partial fraction. Let's say you cannot factorize, what you have to do is you need to use the completing the square. So you will get the fs minus a function. Okay, now we solve example 19. Determine L inverse 5s plus 1 over s squared minus s minus 12. Okay, you use calculator, you will get s plus 3, s minus 4. So you can do 5s plus 1 divided by s squared minus s minus 12 equal to 5s plus 1 divided by s plus 3 s minus 4. Okay, now you can do partial fraction. So a divided by s plus 3 plus b divided by s minus 4. So s minus 4 plus b s plus 3. This one is 5s plus 1. So you can get what is a, what is b. So let s equal to 4. So you will get 4 plus 1 equal to a0 plus b4 plus 3. And then this one is 21 equal to 7b. So b is equal to 3. And then you can let s equal to negative 3. So you get 5 negative 3 plus 1 equal to a negative 3 minus 4 plus b 0. Okay, this one is negative 14 equal to negative 7a. So a is equal to 2. Okay, now you find Laplace inverse. Laplace inverse 5s plus 1 divided by s squared minus s minus 12 equal to Laplace inverse. Okay, a is 2, so 2 over s plus 3. And then plus Laplace inverse b is 3 divided by s minus 4. Okay, equal to, okay, so you refer the formula. Okay, so we get 1 over s minus a is EAT. Okay, so you factorize 2 Laplace inverse 1 over s minus 3 plus 3 Laplace inverse 1 over s minus 4. So for this one, a is equal to negative 3. Let's say a1. For this one, a2 is 4. So your answer should be 2. Exponent a is negative 3. So negative 3t. And then plus 3e 4t. Example 20. Okay, given is 4s squared minus 5s plus 6 divided by s plus 1, s squared plus 4. So already in the term factor. Okay, so what you have to do is you do partial fraction. So 4s squared minus 5s plus 6 divided by s plus 1, s squared plus 4 equal to, okay, the first one is s plus 1. This one is linear. So what you have to do is the numerator must be constant, so a, and then plus, okay, this one is s square plus 4. This one is quadratic. So what you have to do is the numerator must be linear, so bs plus c. Okay, now we proceed. Okay, so the numerator is 4s square minus 5s plus 6 equal to a s square plus 4 plus bs plus c multiply with s plus 1. Okay, let s equal to negative 1. So 4 negative 1 square minus 5 negative 1 plus 6 equal to a negative 1 square plus 4. Okay, plus, okay, so this one becomes 0. So you will get 15 equal to 5a. So a is equal to 3. Okay, now we want to get b or c. Okay, let us get c first. Okay, what we can do is we can let s equal to 0. So we can cancel b. So 4 0 square 5 0 plus 6 equal to a 0 plus 4 plus, okay, 0 plus c 0 plus 1. So we get 6 equal to 4a plus c. Okay, so we know that a is 3. So 6 equal to 12 plus c. C is equal to negative 6. And last, we can let s equal to 1. So we get 4 minus 5 plus 6 equal to a5 plus b plus c 2. So we get 5 equal to 5. Okay, 2 is 3 plus b, we don't know b, and then c is negative 6. Get b equal to 1. Then you can find the Laplace inverse. Laplace inverse 4s square minus 5s plus 6 divided by s plus 1, s square plus 4 equal to a is 3. So 3 over s plus 1 plus b is 1. So s, c is negative 6. So s minus 6 divided by s square plus 4. Okay, Laplace. So Laplace inverse 3 over s plus 1 plus Laplace inverse s minus 6 divided by s square plus 4. Okay, so this one is 3 Laplace inverse 1 over s minus 1. Okay, and then plus, you have to split this. So Laplace inverse s divided by s square plus 4, and then minus Laplace inverse 6 divided by s square plus 4. So you can look at the table. You will get 3e. So a is negative 1, so 3e negative t. And then plus, okay, this one is cos 2t. And then minus, you will get 3 sine 2t. Okay, you can refer back the video before how to get function, how to get the ft, so you can get this answer. Okay, example 20 is completing the square. Let's say you cannot factorize s squared plus 2s plus 17. So you have to do completing the square. The formula as squared plus bs plus c. So you have as squared plus bs plus b divided by 2 square minus b divided by 2 square plus c. Okay, this one is stand for a plus b over 2 square. Okay, so this one is negative b over 2 square plus c. So for this question, s squared plus 2s plus 17. So we have s squared plus 2s, okay, plus b is 2, so 2 divided by 2 square minus b is 2 divided by 2 square plus 17. So this one is s plus 2 divided by 2 is 1, right? Okay. So we get s plus 1 square plus 16. So for this question, Laplace inverse 2s minus 3 divided by s square plus 2s plus 17. You will get Laplace inverse 2s minus 3 divided by s plus 1 square plus 16. So when you refer this one is means that fs minus a. Okay, so what you have to do is we need to make sure this numerator becomes s plus 1 also. Okay, so Laplace inverse 1 2 s plus 1 minus 1 minus 3 divided by s plus 1 square plus 16. So Laplace inverse 2 s plus 1 minus 2 minus 3. So s plus 1 square plus 16. So equal to Laplace inverse 2s plus 1 minus 5 divided by s plus 1 square plus 16. Okay, now you get f s plus minus a. So a is negative 1. S plus 1 is s minus minus 1. So this is a. So f s minus a is equal to 2s minus minus a minus 5 divided by s minus minus a square plus 16. So fs is equal to 2s minus 5 divided by s square plus 16. So you recall Laplace e power of at ft is equal to fs minus a. So from here, what is ft? So ft is equal to Laplace inverse 2s minus 5 divided by s square plus 16. This one you can split. Laplace inverse 2s divided by s square plus 16 minus Laplace inverse 5 divided by s square plus 16. So this one you factor 2, you get Laplace inverse s over s square plus 4 square minus Laplace inverse 4 over s square plus 4 square times 5 divided by 4. So you will get this one is 2 cos 4t minus, so 5 over 4 sin 4t. So Laplace inverse 2s minus 3 divided by s square plus 2s plus 17 is equal to A is negative, so negative t times 2 cos 4t minus 5 over 4 sin 4t.